The rectangular arrangement of elements in rows and columns is called a matrix. The elements from left top corner to the right bottom corner are called as the principal diagonal elements. A diagonal matrix is said to be a scalar matrix if its diagonal elements are equal. Hello, I am Niranjan, Faculty of Mathematics, Vidhyaashram PU College. Now, today I am going to discuss regarding the very easiest and important chapter in mathematics for second PUC, that is matrices and determinants. So the first part is the matrices. Now I am going to discuss regarding the matrices. Now in this chapter you are going to study some definition of matrices, then the construction of matrices, types of matrices, and algebraic operations like addition, the difference, subtraction, multiplication. There are two types of multiplication like scalar multiplication and matrix multiplication of matrices. In addition to that, you are going to study some properties and the transpose of the matrix and then the symmetric of the matrix, and very important concept is elementary transformation, that is row and column operation. So these matrices and determinants will fetch us 8 marks. In this section you are going to get one mark question, 1 mark, and one 3 marks question, that is 3 mark, and one 5 marks question, that is equal to 5 marks. Totally you are going to get 9 marks from this chapter. So 1 mark 1 question, 3 marks 1 question, 5 mark or 1 question. So totally the weightage for this chapter is 9 marks. Now let me begin with the definition. Now what is the definition of a matrix? A matrix is nothing but the rectangular array of elements. The rectangular array of elements in rows and columns. In rows and columns. The rectangular arrangement of elements in rows and columns is called a matrix. What is this rectangular arrangement of rows and columns? The horizontal lines are called the rows. These are called as the rows. And this is first row, second row, third row. These are called as the rows of a matrix. This is the first row and second row. And whereas the vertical lines, these are called as the columns. So this is column of a matrix. So first column, second column, and third column. These are called as the columns of a matrix. That is why the horizontal, that is the horizontal lines are called as the rows and the vertical lines are called as the columns. These are called as the columns of a matrix. So this rectangular arrangement of rows and columns is called as a matrix. So the rectangular arrangement of elements in rows and columns is called a matrix. The horizontal lines is called a row and the vertical lines is called as a column of a matrix. Now, next, the very important concept is the order of a matrix. Now, what is the order of a matrix? Actually, the order of a matrix will define the number of elements present in that matrix. Usually, a order of a matrix is defined as the number of rows into column. The number of rows into number of columns of a matrix. The number of rows into columns of a matrix is called the order. The number of rows into columns is called the order of a matrix. The order will determine the number of elements present in a matrix. Now let us consider, for example, in this matrix, it contains 1, 2 and 3. 3 rows and 2 columns. So therefore, the order of the matrix is 3 cross 2, 3 into 2. So this contains 3 to the 6 elements. Here, this contains first row, second row, first column and second column. Therefore, the order of the matrix is 2 cross 2. Now, in general, the general representation of a matrix of order m cross n is like this. Suppose if a matrix contains m rows and n columns, then it can be represented as it contains m rows, a11, a12, a13, etc., a1n. Then A21, A22, A23, A2n, 31, 32, 33, 3n, etc. M1, M2, M3, Mn. So it contains, these are 1, 2, 3, like this, m rows and 1, 2, 3, 4, n columns. So the order of a matrix is m into n. So it contains m rows, 1, 2, 3, 4, number of m, and columns 1, 2, 3, 4, n columns. So therefore the order of this matrix is m cross n. Now usually for construction of a matrix, we are considering this concept. So a matrix of order 2 rows, 2 columns can be taken as this: A11, A12, A21, A22. First element of row 1, column 1. Then similarly A12 for third row and third column, 3 rows and 3 column, we are going to take A11, A12, A13, A21, A22, A23, A31, A32 and A33. That is first element, second element, third element of row 1, first element, second element, third element of row 2, first element, second element, third element of row 3, row 1, row 2, row 3, column 1, column 2, column. So this is the general representation of a matrix of order m cross n. Now, next, let us come to these types of matrices. So we are going to study different types of matrices. Here, the first one is called a row matrix. Row matrix. Row matrix means a matrix having only one row is called a row matrix. It will have only one row. So how many number of columns? It doesn't mean. You see here, one row. This contains one row. One column, two column, three columns. So 1 into 3. This contains how many row? One row and two columns. Similarly, let us take one more matrix. C is equal to 3, 4, 5, 7. This is also a row matrix. This contains only one row and the number of columns 1, 2, 3, 4 columns. So order is 1 cos 4. Suppose if it contains only one element like this, this is a matrix of order, just row matrix of order 1 into 1. So this is a row matrix. That means a matrix having only one row is called as a row matrix. So these are example for row matrices of order 1 into 3 and 1 into 2. Now, let us come to the second one, column matrix. Column matrix, a matrix having only one column. A matrix having only one column is called a column matrix. So, for example, A, B, C. So, this contains 3 rows, 1 column. This also contains 3 rows and 1 column, 3 rows and 1 column. See another example. This is 1, 2, 4, 5. This is also an example for a column matrix which contains 1, 2, 3, 4 rows and 1 column. These are all example for a column matrix. So, a matrix having only one row is called a row matrix. A matrix having only one column is called as a column matrix. Now, the third one is a square matrix. Square matrix, square means equal. So, if a matrix having number of rows is equal to number of columns is called a square matrix. So here, that is a matrix in which number of rows is equal to number of columns is called a square matrix. The number of rows is equal to number of columns is called a square matrix. So usually square matrices of order 3 cross 3, 2 cross 2 and 1 cross 1. So this is a square matrix of order 3 cross 3, 3, 2, 1, 0, 1, 2, 3, 2, 1. So this contains 1, 2, 3 rows, 1, 2 and 3 columns, 3 cross 3. This contains 2 rows and 2 columns. This is a square matrix of order 2. So this contains only one element. It is a square matrix of order 1 cross. So these are all example for square matrices of order 3, 2 and 1. A square matrix of order 3 means it contains 3 rows and 3 columns. So if number of rows is equal to number of columns in a matrix, such a matrix is called a square matrix. Now, let us come to a square matrix. This is a square matrix, example for a square matrix. In this square matrix, if the elements from left top corner to the right bottom corner, the elements 1, 2, 9 are called the principal diagonal elements. These are called as the principal diagonal elements. Very important point. That is, the elements from left top corner to the right bottom corner are called as the principal diagonal elements. So here 1, 2, 9 are the principal diagonal elements, whereas the elements from left top corner to the right bottom corner like this are called as the secondary diagonal elements. 7, 2, 4 are called the secondary diagonal elements of a matrix. Now, by considering the diagonal elements, let us discuss regarding the next type, that is diagonal matrix. So, diagonal matrix. A square matrix, first of all, it is a square matrix. A square matrix A is said to be a diagonal matrix if all the non-diagonal elements are zeros. All elements are zeros except the principal diagonal elements. So, it is a square matrix in which all the non-diagonal elements are zeros. See, these are the diagonal elements. That is 2, 4, 5 are the diagonal elements and other elements are zeros. This is an example for a diagonal matrix. So, if I consider one more example for a diagonal matrix, B is equal to 3, 0, 0, 4. This is also an example for a diagonal matrix. In general, a square matrix in which all the elements are zeros except the principal diagonal elements, then it is called as a diagonal matrix. Or a matrix A is said to be diagonal matrix if all the non-diagonal elements are zeros except the principal diagonal elements. Let us come to the next, that is the scalar matrix. This is very important. Sometimes they may ask for 1 mark's definition, define a scalar matrix. So, a diagonal matrix is said to be a scalar matrix if its diagonal elements are all equal. Diagonal elements are same. If all the diagonal elements, if all the principal diagonal elements are same and other elements are zeros, such a matrix is called a scalar matrix. So, 3, 0, 0, 0, 3, 0, 0, 0, 3 is an example for a scalar matrix of order 3 cross 3. And 5, 0, 0, 5 is an example for a scalar matrix of order 2 cross 2. So, these are example for scalar matrices of order 2 and 3. So, this is very important definition. A diagonal matrix is said to be a scalar matrix if its diagonal elements are equal. Otherwise, you can also define like this. Scalar matrix. It is a square matrix in which all the principal diagonal elements are same and other elements are zero. Non-diagonal elements are zero. Or it is a diagonal matrix. Diagonal matrix means all elements are zeros except principal diagonal. So, it is a diagonal matrix in which all the principal diagonal elements are same. So, this is also another example for a diagonal scalar matrix. 2, 0, 0, 0, 2, 0, 0, 0, 2 is an example for a scalar matrix. Suppose if I write like this, 2, 0, 0, 0, 2, 0, 0, 1, 2, then this is not a diagonal matrix because this element 1 is not equal to 0. If this is equal to 0, then only this is example for a scalar matrix. Now, next, coming to the next type of matrix, an identity matrix or a unit matrix. Identity matrix or a unit matrix. So, a square matrix in which all the principal diagonal elements are equal to 1. So, a square matrix in which all the principal diagonal elements are equal to 1 and other elements are zeros is called a identity matrix or a unit matrix. It is usually denoted as I. So, I is equal to 1, 0, 0, 1 is an example for 2 rows, 2 columns. Another identity matrix B, 1, 0, 0, 0, 1, 0, 0, 0, 1. This can also be denoted as I. So, this 1, 0, 0, 0, 1, 0, 0, 0, 1 is an example for an identity matrix of order 3 cross 3. So, you can also define like this. It is a scalar matrix in which all the diagonal elements are equal to 1. So, there is other way, a square matrix in which all the principal diagonal elements are equal to 1 and other elements are zeros is called a identity matrix, or it is a scalar matrix in which all the diagonal elements are equal to 1. All the principal diagonal elements are equal to 1 and it is denoted as I. Now, here all identity matrices are example for scalar matrices whereas all scalar matrices are not identity matrices, because this is also an example for a scalar matrix, and a special case is an identity matrix, right? But all identity matrices are scalar matrices, whereas all scalar matrices are not identity matrices. Now, the next one lost in this is zero matrix or a null matrix. Null, nothing. So, a matrix in which all the elements are zeros. So, this is an example for a null matrix of order 1 into 1. This is a null matrix of order 2 into 2. This is an of order 2 cross 3. So, a null matrix is denoted as 0. So, 0 is, this is also an example for a null matrix of order 3 rows and 2 columns. So, these are all the types of matrices. So, first one is row matrix, in which a matrix which contains only one row matrix, column matrix, a matrix which contains only one column. Then square matrix, a square matrix means in which number of rows is equal to number of columns. Next, diagonal matrix, a square matrix is said to be a diagonal if all the non-diagonal elements are 0. 2, 0, 0, 0, 4, 0, 0, 0, 5 is an example for a diagonal matrix. Next one is the scalar matrix. It is a diagonal matrix in which all the diagonal elements are same. 3, 0, 0, 0, 3, 0, 0, 0, 3. And the identity matrix, it is a square matrix in which all the diagonal elements are equal to 1, other elements are zeros, or it is a scalar matrix in which all the diagonal elements are equal to 1 and it is denoted as an I. And the last one is the zero matrix or a null matrix, so which is denoted as 0. Example for null matrices are 0, 0, 0, 0. This is an example for 2 cross 3 matrix, and this is 3 cross 2 matrices. Now, row matrix, identity matrix, and null matrix are non-square matrices, and other matrices are all square matrices. Now, let us come to a problem. So, let us discuss regarding 1 mark problems. That is, now, if this is important, you may get 1 mark questions like this for your final examination. If a matrix has 8 elements, what are the possible orders that can have? As I told in the beginning itself, a matrix of order m cross n means that matrix will contain mn number of elements. If a matrix contains 3 rows 2 columns means it contains 3 into 2 6 elements. So if a matrix having 8 elements, then what are the possible orders that we can write? Now just write down the factors, that's all. So first one is 1 into 8, then 8 into 1. 1 into 8 is 8, 8 into 1 is 8. Again 2 into 4, 2 4s are 8, again 4 into 2. So it contains 4 possible orders. So the possible orders for 8 elements are 1 into 8, 8 into 1, 2 into 4 and 4 into 2. Now let us come to this. So a matrix, write all the possible order of a matrix having 24 elements. Write down the factors for 24. First 1 into 24, then 24 into 1. Next 2 into 12, 2 into 12 is 24, then 12 into 2. Right. Then 3 into 8, 3 into 8 and 8 into 3. Then 4 into 6, 6 into 4. So 1 into 24, 24 into 1, 2 into 12, 12 into 2, then 3 into 8, 8 into 3, 4 into 6 and 6 into 4 are the possible. So totally 1, 2, 3, 4, 5, 6, 7, 8. 8 possible orders we can write for 24. Now let us come to this. A matrix having 13 elements. 13 elements. So the possible orders are 1, 13 and 13, 1. Only 2 possible orders we can write for 13. So if it is an odd number, usually you will get only 2 orders. Now that is how we are going to write the number of possible orders for a given matrix. Now this is also an important problem, the construction of a matrix. Now here what is the problem given? Construct a 2 cross 2 matrix A. A is equal to Aij, where Aij is equal to I by j. Aij is equal to I divided by j. Now What is the order? 2 cross 2. Now let us write A is equal to A11, A12, A21 and A22. First element A11, first element of row 1, second element of row 1, then first element of row 2, second element of row 2. So this is nothing but, what is the condition given? I by j. So 1 by 1, 1 by 2, and this is 2 by 1, 2 by 2. So that is equal to I is 1, 1, ij, ij. Now this is 1 by 1 is equal to 1, 1 by 2, and 2 by 1 is 2 by 2 is equal to 1. So this is a matrix of order 2 cross 2. So 1 by 1, 1 by 2, 2 by 1, 2 by 2, 1, 1 by 2, 2, 1. This is the matrix of the form I by j. Now another matrix, write a matrix of order 3 cross 4 given by Aij is equal to 2i minus j. So for this, what we are going to write? A is equal to 3 cross 4. That is A11, A12, A13. So then A14. 4 columns, 3 rows. Then A21, A22, A23, A24. Again A31, A32, A33, A34. Now this can be written as, what is the condition given? 2i minus j. So see, I will write here A11, that is nothing but 2i minus j. So 2 into 1 minus 1, that is 2 minus 1 is 1. First element is 1. Next A12, 2 into 1 minus 2, that is equal to 0. Next, similarly A13. A13 means 2 into 1 minus 3, that is equal to minus 1. This is minus 1. And A14. So A14, that is nothing but 2 minus 4 is equal to minus 2. This is first row. Second row, A21. So 2 into 2 is 4 minus 1 is equal to 3. The first element is 3. Again A22, that is 2 into 2 minus 2. 4 minus 2 is 2. Next A23, that is, this is minus 3. This is equal to minus 1. Actually this is minus 1. Again 2 into 2 minus 3. 4 minus 3 is equal to plus 1. So similarly A31, 2 into 3 minus 1. 6 minus 1 is 5. Then A32, that is 2 into 3 minus 2. That is 2 into 3, 6 minus 2. 6 minus 2 is equal to 4. Again A33. A33 means 2 into 3 minus 3. 2 to the 6 minus 3 is again 3. And the last element A34. 2 into 3 minus 4. That is nothing but 6 minus 4 is equal to 2. So this is the construction of the matrix 3 cross 4, whose elements are of the form 2i minus j. So what is the important thing is, you should be familiar with writing these elements A11, A12, A21, A22 for 3 rows and 4 column, 3 rows and 4 column like this. Now let us take next type of matrix, next concept, equality of matrices. So equality of matrices. When did you say two matrices are said equal? Two matrices are said to be equal if and only if they are of same order and the corresponding elements are same. Aij is equal to Bij. That means two matrices A is equal to Aij and B is equal to Bij are said to be equal if and only if they are of same order and the corresponding elements are also same. For example, let us take this. A is equal to 2, 3, 4, 5. B is equal to 2, 3, 4, 5. These two matrices are said to be equal and it is denoted as A is equal to B. Now, let us come to this matrix. If A is equal to x1, 3y, B is equal to 2, 1, 3, 5, then these two matrices are said to be equal. A is equal to B if and only if this value of x is equal to 2, x is equal to 2 and the value of y is equal to 5. So, If x and y are replaced by 2 and 5, 2, 1, 3, 5, 2, 1, 3, 5, then these two matrices are said to be equal. Two matrices are said to be equal if and only if they are of same order. Now let us come to the problem. These are all 2 marks questions, very important type questions. So now what is the given? Find the value of A, B, C and D from the following equation. Now by equality of matrices, let us equate this. These elements are equal. So that is 2A plus B is equal to 4A plus B. Then A minus 2B is equal to minus 3. Then third element 5C minus D is equal to 11 and 4C plus 3D is equal to 24. Now let us solve this. So transfer this. This is 4A plus B minus 2A minus B is equal to 0. So plus B minus B gets cancelled. 4 minus 2A is 2A is equal to 0. A is equal to 0 by 2 is equal to 0. So the first value A is equal to 0. Substitute here. If you put A is equal to 0, then 0 minus 2B is equal to minus 3. Minus 2B is equal to minus 3. B is equal to minus 3 by minus 2. So therefore B is equal to 3 by 2. Now substitute the value of, now solve these two equations. So there is no value to substitute C and D. Solving these two equations. So from these two equations, 5C minus D is equal to 11 and 4C plus 3D is equal to 24. Let us multiply this. So simultaneous solution of a simultaneous equation, multiply with this. Multiply this with 1 and 3. So 5 3s are 15C minus 3D is equal to 33. 1 into 4C is 4C plus 3D is equal to 24. Now add, if you add, minus 3D plus 3 gets cancelled. 14 plus 5, 15 plus 4 is 19C is equal to, this is how much you are going to get? 7 and 57. 19 times C is equal to 57. So therefore C is equal to 57 by 19. So 57 by 19, if you divide, how much you will get? 3. C is equal to 3. C is equal to 3. Now then what is to find D from this equation? So 5C minus 11 is equal to D. Put the value of C. 5 into 3 minus 11 is equal to D. Therefore D is equal to 15 minus 11. 15 minus 11 is equal to 4. So A is equal to 0, B is equal to 3 by 2, C is equal to 3 and D is equal to 4. These are the values of A, B and C, D. Now same, let us solve a similar problem. So this is also a same type problem. What is given? These 3 rows, 3 columns are given. What is required to find A, B, C, X and Y and Z? Very simple. Let us by equality of matrix. X plus 3 is equal to 0. Therefore X is equal to minus 3. You will get one value. Then Z plus 4 is equal to 6. Therefore Z is equal to 6 minus 4. Z is equal to 2. So you will get Z value. Next, coming to this, 2y minus 7 is equal to 3y minus 7. So transfer this, minus 7. Minus 7 becomes plus 7 is equal to 3y minus 2y. 0 is equal to y. So y is equal to 0. So x is equal to minus 3, y is equal to 0 and z is equal to 2. Then find out the values of A, B and C. So A minus 1 is equal to minus 3. A minus 1 is equal to minus 3. A is equal to minus 3 plus 1. So A is equal to minus 3 plus 1 is minus 2. Now B, where is B? Here you are going to get B. B minus this. So B minus 3 is equal to 2B plus 4. Then transfer this. Minus 3 minus 4 is equal to 2B minus B. So B is equal to minus 7. Next, the last one is this. 2C plus 2 is equal to 0 here. Corresponding elements. So 2C is equal to minus 2. C is equal to minus 2 by 2 is 1. So this is very easiest way to solve this problem. See, by equality of matrices, x plus 3 is equal to 0. Therefore, x is equal to minus 1. Z plus 4 is equal to 6. Z is equal to 6 minus 4 is 2. 2y minus 7 is equal to 3y minus 7. Transfer this, minus 7 becomes plus 7. 3y minus y is 2. 3y minus 2y is 1y. Y is equal to 0. Again, for A, B and C values, A minus 1 is equal to minus 3. A is equal to, transfer this, minus 3 plus 1 is plus 1. Minus 3 plus 1 is minus 2. Now B, where is B? B minus 3 is equal to 2b plus 4. Transfer this. So 2b minus b is equal to minus 3 minus 4. That is b is equal to minus 7. And finally C value. Where is C? Here it is C. 2c plus 2 is equal to 0. 2c plus 2 is equal to 0. 2c is equal to minus 2. C is equal to minus 2 by 2. Minus 2 by 2 is equal to minus 1. So this is how you are going to solve. Now this is also a same type problem and very important problem, this one. So find the values of x, y and z from the equation. This is very simple. What is given by equality of matrices? X plus y plus z is equal to 9. Okay. Second, x plus z is equal to 5. And the third equation, y plus z is equal to 7. So let us represent this as equation number 1, this as equation number 2, this as equation number 3. Now, just substitute the value. So what is y plus z? Y plus z from equation number 3. From 3, what you will get? Y plus z. This y plus z is equal to 7. So x plus 7 is equal to 9 means x is equal to 9 minus 7. Therefore, x is equal to 2. Okay. Now, so substitute the value. Z is equal to 5 minus x. Z is equal to 5 minus x is equal to 2 is 3. So z is equal to 3. Now from this, y is equal to 7 minus z. That is equal to 7 minus, what is z? 3. This is z. That is equal to 4. So y is equal to 4. Therefore, x is equal to 2, y is equal to 3, z is equal to 4. If you want to verify, for verification, substitute here. Substitute the value of x plus y plus z. So what is here? X plus y plus z is equal to 9. What is x? 2. What is y? 3. What is z? 4. What is this? 4 plus 3, 7 plus 2 is 9. So x plus y plus z is equal to 9. This is very simple and very easiest and important problem. Now next, take this problem. X plus y is equal to 2. So from this, x plus y is equal to 6. Then 5 minus z is equal to 5. Xy is equal to 8. So y is equal to 6 minus x. Here 5 minus 5 is equal to z. Z is equal to 0. Now what is the value of, substitute the value of y here. This is x into y is equal to 6 minus x is equal to 8. This is 6x minus x square is equal to 8. Transfer this. 8 plus x square minus 6x is equal to 0. Put it in order. X square minus 6x plus 8 is equal to 0. A quadratic equation. So 8 can be written as 4 into 2. Factorize this 6x. So this can be written as x square minus 2x minus 4x plus 8 is equal to 0. Factorize 8 can be written as 2 into 4. Minus 2x minus 4x is minus 6x. This is one group, this is another group. You can remove x common factor, x minus 2. Minus 4 common factor, x minus 2 is equal to 0. So x minus 2 into x minus 4 are the factors. X minus 2 is equal to 0 or x minus 4 is equal to 0. X is equal to 2 or x is equal to 4. So the values of x are x is equal to 2 and x is equal to 4 are the values of x in this equation. Question. This is also important question. This question they may ask in CET also. This is important for CET, your KSET examination. The number of all possible matrices of order 3 cross 3 with an entry 0 and 1. So 3 cross 3, as I told in the order of the matrix itself, 3 cross 3 means it contains 9 number of elements. Since 0 and 1, so 0 and 1 there are 2 elements. So the number of possible matrices of order 3 cross 3, 0 and 1 as the entry. So there are 2 elements, 0 and 1 as the 2. So therefore the possible orders can be written as, so 2 into 2 into 2, 2 into 2 into 2, how many times? 9 times. So that is nothing but 2 to the power of 9. So 202 to the power of 9 can be written as 512. So this is how you are going to write the number of possible matrices for 3 cross 3 whose entries are 0 and 1 is, so 2 into 2 into 2, 9. So that is 2 to the power of 9, that can be written as 512. Since there are 2 entries, 2 elements can be put it in the form of 9. So 2 to the power of 9, which gives 512, are the number of possible matrices with elements 0 and 1 for 3 rows and 3 columns. So that's regarding definition and a few problems related to this equality of matrices. Now that's all for today's class. We'll meet again in the next class with problems based on algebra of matrices. Thank you.